All right, so let's get started. So what am I going to present? I'm going to present to you a couple of, well, we've decided we're going to do two new maps. One is going to be a regional map that's going to show where southwestern Ontario is with respect to the Michigan and Appalachian basins. That one we're currently working on. I'm not going to show you that today, but I'm going to show you snippets, little pieces that are going to be part of this new promotional map and poster. It's actually called the Exploring Ontario Atlas. Now, why is it an atlas? Because this is a roadmap for all the plays that we geologists feel are economic and viable plays still left here in southern Ontario to be explored and developed. And we want some of the newcomers that are here, like Alex and Laurent and other people, to help us to look for these new plays that could be out there. But I'm going to show you today is the old conventional plays, what we feel is still very viable. We'll work our way from the top and work our way down. There are 4 main plays by age, but 6 play concepts that we are promoting with this new poster, this atlas. We'll start with the Devonian anticlinal oil play. Now, we know historically that oil has been produced from the Dundee and Lucas. I've studied this play for the last year and a half very intensely from core and cuttings. And I can tell you that it's the Columbus member of the Dundee Formation that is very, very important in this play concept. And you can find that about 400 to 500 feet below the surface. Now, we are promoting the Pinnacle Reef play here in southern Ontario. It's an oil and a gas play, and you can see down at the Niagara, this is where we look for the Pinnacle Reefs. They can be found at 1,500 to 2,100 feet at depth in North Lambton and Huron counties. We're also going to take a quick peek at the Ordovician oil and gas play. Now, this is a little bit of a place where I have a little bit of expertise. This is the hydrothermal dolomites of the Middle Ordovician group, Middle Ordovician Trenton and Black River group carbonates. We'll have a look at both the oil and the gas play there. They can be found at 1,900 to 3,100 feet below the surface. And we'll have a look at the Cambrian horse block play. The Cambrian has produced oil out of the Eau Claire, and again, this is a play that I've been studying very much so for a couple of years. And it's the upper units of that Eau Claire that are very important reservoirs, Eau Claire units 1 and 2, and we find that Eau Claire units 1 through 4 can be hydrocarbon saturated and potential reservoir over a very large area in Ontario. This can be found at depths between 2,900 and 4,000 feet below the surface. Okay, so for the next series of slides, I have a key put in here. The Devonian will always be in your upper left, Silurian upper right, Ordovician lower left, and the Cambrian lower right. Now, what we have here is a series of maps that was produced by Terry Carter for the CSPG and other publications. This shows the play fairways for the various pools, the various play types in Ontario. So the Devonian anticlinal oil play you can find here in Kent County, West Elgin, and all of Lambton County. Now, the Devonian oil play has produced about 45 million barrels of oil to date. Let's jump over here to the Silurian. You could put the Algonquin Arch axis right in through here. What we have here, of course, is a rendering of all the carbonate plays in southern Ontario. Let's say that everything to the north and west is Michigan Basin, and to the south and east is Appalachian Basin, just for simplicity's sake. Now, this play as a whole has produced about 15 million barrels of oil, 330 BCF of gas onshore, and 450 BCF of gas offshore. And of course, there's still some, potential out there offshore. Let's look at the Ordovician. This is the traditional fairway for those hydrothermally altered Trenton and Black River group dolomites. Again, it's mostly in Essex County and West and North Kent County, going up towards Lambton County. Now, the Ordovician has produced about 23 million barrels of oil and 40 BCF of gas. Here we have the play fairway for the Cambrian. There's really just 4 very large pools here, spread over a very long distance. The Cambrian has produced about 5 million barrels of oil from three pools, Clearville, Willie, Gobles, and about 26 BCF of gas out of Innerkip. Okay, we'll take a little closer look at each of the plays, and we'll talk a little bit about their future potential. Again, up in the left corner, we have a Devonian. This is the Devonian Fairway, and it's a Devonian Fairway for two reasons. Number one, you need to have those Columbus sands and sandy dolomites. Number two, you got to be in the salt basin. The salt dissolution is very, very important and part of the anticlinal trap feature. Now, some of the key fields are like Rodney at 10.7 million barrels, Petroleum up here, very old, almost 19 million barrels. You got Glencoe at 1.1 million barrels. These are very nice pools. The future potential, according to the experts, somewhere between 20 and 30 million barrels left to be discovered and developed. Now we'll go over here to the carbonate play. Now, Bailey and Cochrane did a series of reports. They suggest for the entire carbonate play, there's another 3 to 5 million barrels of oil, probably somewhere between 300 and 500 BCF of natural gas. A lot of that's going to come from the offshore and the Appalachian basin side of things. But for pinnacle reefs, we're suggesting that you should be looking for reefs that can contain 100,000 barrels of oil up to a million, and reefs that are about 1 to 2 BCF in size. This is going to come from northern Lambton County and, of course, Huron County. Yeah, southern Bruce probably as well, according to what, Dave would agree with that. Okay, so down in the lower left corner, here we have the Ordovician. Boulder in 2005 released a report, an economic assessment of this play, and they said that the Ordovician could probably produce another 17 million barrels of oil. I would suggest that 17 million barrels is going to come somewhere out of the traditional fairway here as part of the Michigan Basin petroleum system. Now, they also said that there are 240 BCF of gas is possible. Well, I would suggest that the bulk of that would have to come out of the Appalachian Basin side of things, because, these little pools that you see up here, these little circles, they're kind of fractured Trenton and Black River carbonates with gas in them. They're kind of a little indication that down here we're going to have some nice traps for the Ordovician, and it's going to be dominantly gas. If you look at the petroleum system out of the Appalachia, Pennsylvania, New York State, they are all gas pools. Lower right, of course, we have the fairway for the Cambrian. Again, it's a distribution of those those pools. Now, the Cambrian, the horse play that we're talking about here, the horse block play, is supposed to have a total potential of 130 million barrels. We produce 5. We got a long way to go for that one. So, it's supposed to be promotional material. We're going to help people understand the plays here in southwestern Ontario. Best way to do that is to show them some analog pools, right, Ed? So we picked the Rodney oil pool for the Devonian. Now what we have here is a structure contour map. This is the geology from a myriad of wells, probably well over 300 wells, that show that the Dundee here is on a very prominent north-south high. There's a very big low over to the west. We also see a low over here to the east. This is part of that anticlinal structure that we're talking about. Let's move over to the Silurian. This is a structure contour map, top of the Guelph Formation. Basically what it shows is the structure contours change very rapidly, and we have a very nice, broad, pointy feature called a pinnacle reef. And what we've outlined here in the purple is that productive area of the reef. So it gives you an idea of what the geology rendering of a pinnacle reef looks like. Down on the lower left corner, we have the structure contour of the top of the Trenton or top of the Coburg for the Rochester oil pool. What this shows, again, is these long, elongated, low structures, these synclinal sags that were formed by wrench faulting. On the bottom right, we have the structure contour map for the top of the Shadow Lake. This is a thin shale unit on top of the Cambrian. This is done by Bailey and Cochrane. They put in some very nice faulting in here, but what they show is that these structure contours show that these horse blocks are actually tilted. This is tilted up towards the northeast and down towards the south-southwest. Even north is kind of pointing that way. So here's your analog pools. We'll continue this with the next set of slides. Now, how do you go about finding these things? Well, you're going to have to start using remote sensing tools such as gravity and magnetics. So we'll do it over some of these analog pools that we have. Now, this is the total mag intensity map over the Rodney oil pool. You can see it sits on top of a very broad magnetic high. Highs are in light pinks. The lows are over here in the yellow. Now the first, okay, if you know anything about magnetics, I mean, magnetics is showing us that there's density contrast down in the basement. So we know these are basement structures. Also, if you look at the first derivative, you can start coming up with structural elements like lineament directions. So we see that there's a strong northwest, southeast lineament direction here. There's another northeast, southwest. There's even indications of an east-west. These are very, very prominent faults that are very important that set up a lot of the traps here in southern Ontario. Let's go over to the Silurian. Now we have the P.Geo gravity map for the Don 156 pool. Now Don 156 is very important because there's a couple of key elements. Number one is a pinnacle reef complex. It's fully dolomitized, and there's a salt hole sitting on top of it. So gravity is fantastic for picking up the density contrast you're going to see from the salt, no salt, and also the dolomite from a very large complex sitting in a sea of tight limestone. You also see, you can start picking up some structural elements like a strong north-south kind of lineament. You can also see, well, we know that these salt holes form along these east-west type lineaments, and it looks like we have something developing over here, and I think someone should go have a look at what that is all about. Let's go to the bottom left corner here. We have the first derivative of the magnetics for the Rochester oil pool. Now what we have here is a series of highs and lows. More importantly, what we're seeing here again is the development of structural elements. These structural elements, of course, are those basement faults, the northwest, southeast faults that made these negative flower structures or wrench fault systems. So you can start looking at putting in faults in different places. On the bottom right, we have total mag intensity for the Clearville oil pool. You can see that the Clearville is sitting on a nice magnetic high. We have really big lows over to the northwest and to the southeast. What I really want to show you is that the geology really ties well to what we're seeing here for interpreting lineaments, like the northwest-southeast lineament here, the north-south, and you can also see the development of these east-west lineaments. Again, these are very important fault systems that control a lot of the reservoirs here in southwestern Ontario. All right, so why do we do this? We do this because we need to see what these look like before you shoot your seismic. You need seismic because you want to know where to put your well. Well, let's take a look at a seismic section here for the Devonian. Now, this is the productive area of the Rodney oil pool in green. What you're seeing down here in the yellow, of course, this is a coloration of the B salt. Now, this solution of the B salt is very, very important because it sets up the formation of these anticlinal features. When you go to the western extent of the Rodney oil field, you can see that the salt comes off very quickly. That's only over 150 meter distance. You go from over 200 feet of salt to zero very quick. Now on the east side, you see more of a gradual thinning of that salt, but there is another fault over to the east, and that salt drops off close to zero again. Now another thing I want to show you and point out, this is Duncan Hamilton's rendering of the Rodney oil pool. He's also put in here the Hamilton Shale. Now this is very important because the Hamilton Shale doesn't exist on top of the Rodney oil pool. This is what we call a geological inlier, where we have older rock sitting in a sea of younger rock. And if you look very closely, it looks like it even maybe onlaps a little bit. So I can give you indications of the timing of all these things. Okay, so what we think we know is that, especially during the Acadian Orogeny, we had these major fault blocks formed. Faults coming up all the way from the basement, go all the way to each section. Stop. Thank you very much. And what that did is that started the dissolution of the B-salt. Now we think that during various unconformable events, like at the Bass Islands or the Columbus, shallow circulating fluids came down and started dissolving out these salts, creating the anticlinal feature that you see here for the Devonian. And it may be even later events, we're not sure. It could be definitely Acadian, but maybe even the Allegheny that contributed to popping up these horse blocks even more, giving rise to that geological inlier that we see between the Dundee rocks here. This is the Dundee here, the Columbus, and the Lucas is sitting up against a very tight Hamilton Shale. Now, as Jordan lets us wind through again, I'll just let it go all the way. So you can see that this is very, very important in the formation of the anticlinal feature. More importantly, porous rocks sitting up against very tight shales for your lateral seal. The top seal here is, of course, the tight Dundee limestone. Okay, so we also did some economics, and this is all the hard efforts of Jim McIntosh, I had Matt Dupont do a kind of a historical rendering of all the pool sizes in Ontario. And from that, I did an analysis myself of missing pool sizes and assigned pool classes and everything. This gave Jim the basis to be able to pick his small, medium, and large sizes. So again, for the Devonian, we got the type of trap, type of formation, area, the number of wells you would drill, the reservoir, the various parameters, porosity, permeability, IP, expected IPs, and of course the prize, which is the 38 API oil. Now all of these economics are based on the current commodity price that you would fetch by drilling a Devonian pool. So this is very rigorous. I mean, Jim's spreadsheets are 111 pages backing up all this stuff, so you can just imagine how much effort's gone into this. Some of the key things in the economics, what people want to see is the net present value discounted at 10%. There's got to be some risk in there somewhere, right? Now these are positive economics, not the risk economics that we would use to, high grade and rank our internal prospects. This is all about if you found something, whether it was on seismic or you've drilled it, it's not quite what you're liking. A small pool here has a negative NPV and a zero rate of return. Well, that's because lessons learned from developing these small pools, we want to discourage people from wasting their money. Let's take a look at the medium and large sizes. Very economic. We also have the capital cost per flowing BOE. These metrics are very important when you're buying and selling assets. And of course, your rate of return. Now, I want you to notice the rate of return for the rest of these prospects that we go through. Okay, here is a typical seismic section for a Silurian reef. Okay, this is not a known reef. Unfortunately, we weren't able to convince anyone to let us show you it. This is a gentleman has provided this to us so we can look at his rendering of what's important for identifying pinnacle reefs on seismic. So I won't tell you who it is or where it is. First of all, we have his basement fault that would have set up a local high during the Gasport Goat Island time, where this would have set up the growth of these pinnacle reefs. So this is what you're seeing here. On seismic, you want to see the dissolution of the A2 salt and the thinning of the A2 carb, or at least that's what it looks like on the seismic section. And of course, these reefs tend to look like they're punching up into the B salt. So from a seismic perspective, here you go. Okay, so we're just going to look at some formations like Gasport Goat Island, the Guelph, A1 evaporite, carbonate, the A2 anhydrite, A2 carbonate and salt. What's important here is that we got the Guelph bioharmal reef. What we see from the drilling is that there's lots of A1 carbonate. This is your lateral seal for these pinnacle reefs. Your top seal is the A2 anhydrite. Of course, we always see the expression on top of the B salt and the A2 carbonate. So through time, of course, fluids came in, kind of dolomitized the reservoir, dolomitized the A2, dolomitized the A1, dolomitized the Guelph, and then of course the hydrocarbons came in. Now we're just showing you an example. This is not a one-size-fits-all kind of thing. This is an oil reef, so if you would have drilled into it, you would have saw shows in the A2, shows in the A1, and your bulk of your oil would be coming from the Guelph. Pretty cool, huh? All right, so we have our economic analysis for our type pools. Again, we presented the small, medium, and large sizes. We're listing the type of traps, producing formation, your area, your number of wells that you would drill into these things. Yeah, typical type of production you might expect, lithology of your reservoir, your net pay porosity, all those wonderful metrics, wonderful things that you need to see to understand these plays from a geological and engineering point of view. Now, of course, let's take a look at the economics here for these pinnacle reefs. You see that the oil case looks much more attractive than the gas. However, the rate of returns here show that both of these are very desirable prospects to have. And of course, we provided you with a negative because we want you to stay away from the smaller features, lessons learned. And of course, all the economics are based on the current commodity prices that you would fetch for both oil and gas in pinnacle reefs. Of course, the capital cost per flowing, these metrics, again, very vital to anyone's analysis of these prospects. Let's move on to the Ordovician. We have the 3Ds, there's two 3Ds over the Rochester oil pool, and this is an inline taking from one of the 3Ds. The key features that we're looking at here, of course, is the sag or the lows at the top of the Trenton and the Cambrian. You also see a bit of a sag at the Clinton or Rochester. Important elements, of course, is these bounding faults are very active, but they do not seen to penetrate above the Silurian. Very, very important. If you isochrone the top Rochester to the top of the Trenton, you'll see there's an apparent thickening within these productive features. And you definitely don't want faulting during the Silurian or Devonian times because you won't have a reservoir. Now let's run the model for this one. This would be, say, during the Taconic Orogeny, where we would have had these wrench faults and lateral shearing going on. And then what this would have done is would have allowed for faulting to take place, formation of these negative flower structures. These rocks kind of collapse into the center of the structure. Fluids would have came in much later on, likely Alleghenian or post-Alleghenian. It would have dolomitized these rocks and also created the reservoir and brought in the hydrocarbons. Two things are important. Number one, you need a Cambrian, you need a conduit for those fluids. Number two, these faults do not extend above the Silurian. Otherwise, you're going to have an over-dolomitized feature or a breached reservoir. Lessons learned. Okay, let's move on to the economics. Again, our type pools, small, medium, large sizes. You know, again, it's just type of trap. It's all the same vitals, as Ed would call it, for the play. And as we move all the way over to the right, we'll get to the fun part, which is the economics. Now we have it for both the Ordovician gas and the oil play. Again, we're providing small pool analysis, trying to make sure people don't waste their money on small pools. You can see even the gas is pretty good. If you find a nice, based on our modeling and knowledge of the size of the pools for gas, you could definitely make some money at that. Obviously, the Ordovician oil is the major, desirable feature here. And notice that rate of return here is getting much nicer as we go deeper. Okay, let's look at the Cambrian. All right, again, gentleman provided a prospect for the Cambrian. This is not over a known trap. I do have seismic over at known, but I wasn't allowed to show it to you. So this gentleman has doctored it up. It's got the Cambrian highlighted, Ordovician, Silurian, and Devonian. Again, we have these large basement faults. These are likely, I would suggest Acadian in age. These faults go all the way up through into the Devonian section. There may have been some further movement during Alleghenian. But anyway, what's very important here is he's got the Cambrian juxtaposed up against tight limestones of the Gull River Formation. And that's basically your trap. So we'll run the model for this one. Here you go. You got the faulting, formation of a tilted horse block. We're just showing the pre-Cambrian, Cambrian, and Black River for now. Just a kind of a close-up of what the Cambrian trap looks like. Fluids would have came in later on and created the reservoir, and then we would have had the hydrocarbons come in shortly thereafter. This is kind of a tilted horse block similar to Clearville, showing the tilted nature of the hydrocarbons within that reservoir as well. Now again, all these models are very, very high level. We're not getting into the nitty-gritty of all. This is not a one-size-fits-all, but definitely one of the ones that we understand and know very well here. Okay, again, for the Cambrian Economics, for the Clearville oil pool, small, medium, large sizes, we have all of the vitals again, type of trap, expected production, lithology of the reservoir, all the vitals you need, net pay, porosity, IPs, and of course, the oil, the quality of the oil. And what you can see here again is that the Cambrian is very, very economic, but the rate of return here is phenomenal. And as you go deeper, you see that our rate of return gets a little better. That's kind of interesting because we also want to promote that this play is the most underexplored and underdeveloped play in Ontario, and it needs some attention. The end game here is to promote the Ontario oil and gas industry, and we're trying to develop a map, which I have a hard copy I can show you. It's kind of a rendering of this. In the end, we want to create a new booth for the OPI that'll have panels for each of the Devonian, Silurian, Ordovician, and Cambrian. All of those key elements will be on there. The geology, the geophysics, the seismic renderings, all that stuff. And prominently, we'll have the economics so that we can let the people that don't understand Ontario have a good idea of what is prospective here and what we think is left to go find. All right, thank you very much.